Solubility is the amount of solute that will dissolve in a solvent. We just covered whether or not a solute would dissolve. Now we want to be able to determine how much of that solute will dissolve. And there's a couple of things that we have to consider. First of all, the identity of the solute and the identity of the solvent. And again, that goes to our last lesson of, is it polar? Is it non-polar? What are you dissolving it in? And then the other two factors are temperature and pressure. So keep in mind that the dissolving process is, related to the amount of collisions that are happening. So temperature and pressure are both related to those collisions. We can actually graph out the solubility of a substance based on temperature. And we can do that with what's called a solubility curve. Rule number one, you must always read the axes with these graphs. For the most part, if you look at the y-axis, it tells you the solubility of, and then whatever your solute is, and then there's a line. That line is per or over 100 grams of water. So they're comparing whatever it is that you're experimenting with if you had 100 grams of water. Then the x-axis is temperature. Generally, because of collisions, as temperature increases, you can dissolve more. So how would we read this graph? It says 100 milliliters of 60-degree water can hold how much sodium chloride? So I need to find 60 degrees on the x-axis. Okay, now this whole graph is for 100 mils of water. So that's telling me all I have to do is read that graph. So where does 60 degrees meet up with this line? So, it's going to be 37 grams. I can dissolve 37 grams of sodium chloride if I have 100 milliliters of 60-degree water. Let's try another one. Same graph, but this time I have 200 milliliters of 100-degree water. Well, this graph is only for 100 grams of water. Does that mean I can't use this graph? No, I can actually set up a ratio. So first, I still need to read the graph for 100 degrees of water. So 100 degrees is over here on the right. And if I go all the way up, that's where my dot is. And then I bring it over to the left, that should be 39. This graph tells me that if I have 39 grams of salt, it will dissolve in 100 grams of water. But I don't have 100 grams of water. I have 200 milliliters. So first of all, water has a density of 1 gram per mil. This is from our conversion unit. So 1 gram of water equals 1 milliliter of water. This only works for water, okay? So 200 milliliters is the same thing as 200 grams. So all I need to do is set up a ratio and go, 39 grams will dissolve in 100 grams. How many? Hey, isn't 200 twice as much? So if I have twice as much water, I should be able to dissolve twice as much salt. So I just set up a ratio and I still use the exact same graph. Besides being able to read the graph and determine the amount, I want to also kind of figure out what that solution would look like or classify the solution in some way. So here this is saying if 40 grams of salt are added to 100 mils of 25-degree water, what would it look like? Okay, so I need to find 25. 25 is like halfway through here somewhere, right? And then it's going to be 40 grams of salt. Oh my gosh, that's like way up there. That's just ridiculous, okay? So the line right here, this line represents the maximum amount of solute that you can dissolve. And if it has the maximum amount, we say that that solution is saturated. For those of you that like taking pictures on your phone, if you go in and you edit, you can usually edit the saturation of your picture. You can create your color pixels and you can basically have them have the maximum amount of color. Or you can unsaturate your photo and you can remove all of the color and you can make it black and white. So again, it refers to the amount of stuff that something can hold, whether it's color in your photo or solute in your solution. So if it's on the line, it's saturated. Now, if it was 40 grams and it's over the line, we still say that that solution is saturated. The solution itself is still holding the maximum amount. But then you have extra. So what happens to that extra stuff? It settles out. It goes to the bottom. It's what we call a precipitate, when you have that solid hanging out at the bottom of your liquid. Okay, so if it's above the line, it's still saturated because you still have particles dissolved in your solution. You just have all the extra stuff chilling on the bottom. If you have less than the maximum amount, if you have something below the line, we say that it is unsaturated. So based on where your point is, you should be able to classify if something is saturated or unsaturated. There is one more classification. Super saturated. Okay, this is where you've done something to your solvent and you forced it to hold more than it usually can. You've altered its temperature or its pressure to where it's not acting normal. This actually is an unstable solution. And so this supersaturated state won't hold for very long. So if it's ever going to be super saturated, it has to be above the line and it has to say that all of it dissolved, meaning you don't have any extra precipitate hanging out on the bottom. So those are your three classifications. Below the line, unsaturated. On the line, above the line, saturated. Above the line and all of it dissolved is supersaturated. So I've got a graph now, and this graph actually has three different substances. So besides reading the axes, you also have to read the labels on the line. It'll tell you, oh, this line represents potassium nitrate, and this line represents potassium chloride, and this line represents sodium chloride. So for A, I have 31 grams of potassium chloride. So I need to read the potassium chloride one. And it's 30 degrees. So I need to find my 30 degrees. And then where am I going to put that at? So 30 degrees and 31 grams. So about right there. Comparing that dot to the potassium chloride line, it looks a little below the line. So if it's below the line, I would say it's unsaturated. For B, I have 106 grams of potassium nitrate at 60 degrees. So I need to find my 60 degrees, and I'm going to take it all the way up to 106. It's about right there. Now, where is that dot related to potassium? Oh, this is the line for potassium. It's smack dab on that line. That's going to be saturated. What about this problem? It says how much of the solute will dissolve and how much will remain undissolved at the bottom of the test tube. So it's already telling you you're adding too much, right? So you need to figure out how much will dissolve first. So you have 80-degree water. So 80-degree water of potassium nitrate. So 80 degrees Potassium nitrate. How much is that? Okay, so that looks like what? Like, is that like 170, 169 or something like that? That's how much will dissolve. But it tells you you have 180. You have that little bit of extra. So what you need to do is you need to subtract the difference between the two. So if I say 169 grams will dissolve, well, I have 11 grams left over. So I will have 11 grams of precipitate sitting at the bottom of my test tube that will not dissolve. This one's also interesting. A saturated solution, so I'm telling you it's saturated, of potassium nitrate is formed in 100 grams of water. Okay, so that just means I can use the graph exactly as is. If the saturated solution is cooled from 90 degrees to 30 degrees. Okay, so that means that when we made the solution, it was at 90 degrees. So 90 degrees and saturated. 90 degrees, and then saturated means it's on the line. It's like way up there, okay? I'm making a solution, that's like what, 200 grams? So if I'm gonna make a solution that's saturated at 90 degrees, that can hold about 200 grams. But then it gets cooled down to 30 degrees. Okay, so 30 degrees. Oh, wow. It goes down a lot, doesn't it? So that's kind of like at what, like 46 or 45? How many grams of precipitate are formed? Well, what's the difference between the two lines? At 90 degrees, it can hold 200 grams. At 30 degrees, it can only hold 45. So that means 155 grams are going to precipitate out or settle out of solution and be hanging out on the bottom of your beaker or the bottom of your test tube. Here's another problem. How many grams of potassium chloride can dissolve in 50 milliliters of water at 80 degrees? Notice I bolded this for you. This graph is for 100 grams of water, but I only have 50. This tells me that I have to set up a ratio. I can still use the graph as is, but 80 degrees and potassium chloride, that means that my solution can only hold 50 grams. So 50 grams of potassium chloride will dissolve in 100 grams of water. That's what the graph tells me. But I don't have 100 grams of water. I have 50 grams of water. Again, remember, for water, 1 milliliter equals 1 gram. I set up my ratio here. If you want to, you can cross multiply. Or isn't 50 half of 100? So what's half of 50? 25 grams. These are some examples of how to read solubility curves and the information that you can get from them.